everybody, very warm welcome to Vedantu JEE English channel. This is me, your master teacher Nabamita Bhattacharya, and today, what are we doing? We are taking a look at the first chapter of class 11, that is some basic concepts of chemistry. Now, before you start complaining, before you say something else, please let me clarify that we have endless number of plans. One of the plan is that we will be taking 2 to 3 topics every day or alternate days, and we will be completing the chapter. Apart from this, I am personally also planning to finish your complete syllabus in 1 month for your class 11, so that those of you who are aiming for 2020 for JEE and you are in 12th class, you get a complete revision in just 1 month. Okay. And along with it, we will also be doing class 12. So everything should go hand in hand. These are the plans. Now, coming to why should we read this chapter? That's because, let me show you the last 3 years JEE mains weightage here. In 2020-22, we saw that 44% of the questions were, not 44, I mean 44% questions had come from this chapter, okay? Then in 2020 it was 18%, 2021 it was 38%. So this is the JEE mains 3 years weightage. From where have I taken this data? I have taken this data from MTG Explorer, that brand of book that you know. From there I have taken this data. Okay, so in the year 2020-22 we saw that the number of questions from this chapter had increased. So what we are learning today is, today we will be starting from the very basic of this chapter, as in what is chemistry, what are the laws of chemical combination, what is density, what is mass, what is volume, and all of these. So I understand for some of you it might be very basic, but as a teacher my duty is to teach you from the very basic and not leave anything. Obviously we will not be finishing the whole chapter since we are doing this chapter for the first time. I am taking this chapter for the first time in this channel. I will not be skipping anything and I will be taking care of the whole chapter. So we will not be completing the whole chapter in one day. Okay, so now let's begin. Now the first question that comes in our mind is, what exactly is chemistry? And that is something that this chapter tries to answer, right? So what is chemistry? Chemistry is actually that field of science which deals with atoms and molecules and their transformations, right? Transformations, you know, right? That Transformer movie, did you see how the car transforms into a robot kind of thing? Transform, right? It transforms, exactly, something like that. Now, do you know that this field, right, chemistry, this subject, none of us were trying to find it. None of us were trying to discover it, okay? Yes, something like an unwanted thing it is. But then how did we step into it? Well, human beings, you know, I always say this, that human beings are the most horrible creature. You don't believe me? Let me tell you, you know what? Even from the olden days, there were only 2 ambitions that we had. One was to be immortal, not to ever die. And the second one was that we wanted to be rich. And that's exactly what we wanted to find out. We wanted to find out a philosopher's stone here. Yes, we wanted to find a philosopher's stone. Now, what is this philosopher's stone? What will this philosopher's stone do? We expected that the philosopher's stone will touch all the baser metals like iron or nickel or cobalt, and it will convert it into gold. Alright? Yes, that's what we expected. Second thing that we wanted to find out was elixir of life. And why? Why this? Because we wanted to be immortal. Yes, we wanted to be immortal. So do you realize that we wanted to be immortal, we wanted to never die, and we wanted to be rich. So these two discoveries, not discovered, we haven't discovered it yet. We wanted to discover this and accidentally we stepped into chemistry. And you know, to be very honest, from the very old days, we have seen that the archaeologists, they dug out something and they found out that mud bricks, roasted mud bricks were used. just like how we use bricks nowadays. And that can be considered as one of the first chemical processes that were used. Yes? So that's how we stepped into chemistry, that's how chemistry came into our picture and all of this. Now I hope that you understand the history of chemistry. Now let's go into the mystery of chemistry. Yes? So in chemistry, even from our younger classes, we know that matter. We keep talking about matter. What is this matter? We all know that matter is anything that occupies space and has volume. What is volume? We will talk about it. But let's write it down here, okay? Matter is anything that occupies space, okay? Matter is anything that occupies space and has volume. Alright? Now what are the examples of matter? You know what? Anything and everything. The stones that you throw, the food that you eat, the air that you breathe, the water that you drink, yes, the pen that you poke your friends with, the pen that you write with, the pencil that you use, the eraser that you use, anything and everything is matter. Right? So obviously now that there are so much matter in this whole world, you understand that we definitely have divided matter into 3 states. Okay? 3 states. Matter has 3 states. Yes, and what are the 3 states? I'm sure that all of you know. Of course, it is solid, liquid and gas. Right? Solid, as we all know that the particles are very closely bound to each other. The particles have really strong intermolecular forces and that's why you cannot break them. They are rigid. They are not compressible. You cannot just compress them like this. They have fixed shape. Look at this blackboard. Look at this remote. Look at this pen. Everything has a fixed shape and of course a fixed volume and they cannot be squashed, which I have just told you. Now moving forward to liquid. What about liquid? Liquid is obviously not rigid, right? They flow. Both liquid and gas, they flow and that's why we call them to be fluid, isn't it? Because they flow, right? Because they flow, we call them to be fluid, right? So liquid is not rigid. They do not have fixed shape. You must have seen that if you keep water in a bucket, it takes a bucket shape. If you keep water in a bottle, it takes the shape of the bottle. If you keep it in a mug, it takes the shape of the mug, right? Yes, so it keeps changing its shape. That means it does not have a fixed shape. Alright. Now, talking about fixed volume. This is very important, my dear student. Please understand this, okay? Let's just say that this bottle, I don't know if you can see it, but there is a little bit of water in it. Can you see? No, probably not. Anyway. So this bottle can keep 1 liter, let's say, okay. I can keep 1 liter of water in this bottle. Now imagine if this bottle is completely filled. If it is completely filled and then if I pour this bottle in a bucket, what will happen? Do you think that the 1 liter of water will it change into 50 liter? Not possible at all. 1 liter of water will remain as 1 liter only. The volume won't change. And that is exactly what it is trying to say, that it has fixed volume. It has fixed volume. Getting it, my dear student? And of course, it cannot be squashed. Now, this is not truly correct, okay? Liquid, if you take, let's say that you have a bucket of water, right? Now, if you try to punch it, what will happen? Your hand will go inside, there will be splash of water, but your hands will not reach the bottom of the bucket. Will it? It won't. It won't. It will only reach to some extent and then it will stop. Am I right? So it cannot be squashed as much as you can squash the gas, but it can be squashed slightly more than the solid. Understood? Yes? Now we move to gas. Gases obviously are not rigid. If here is a molecule, then there is another molecule, right? There is a huge gap. The intermolecular forces are very less. You can completely detach them very easily. They do not have any fixed shape, and this time they do not have fixed volume also. Okay, let me give you an example. Alright, let me give you an example. Okay, Lay's packet, Lay's chips. You all have eaten Lay's chips, right? If you buy 5 rupees Lay's chips, you only get 5 chips, isn't it? Rest everything is air. Rest everything is air in it. Now if you tear the packet, what happens? Psst. The air comes out and mixes with the nature, right? Right? But that's not exactly the volume change. That is also a volume change, because the air from the nature also occupies the space that was empty. Alright? But another example, let me give you another example. What if, now imagine instead of water there is gas in it. Now let's say that if there is 1 liter gas in it and if I pour it into a bucket, then now do you know what will happen? The gas will occupy all the space in the bucket and the volume of the gas will also change according to the bucket. Yes. If the bucket can occupy 50 liter, then the gas will change its volume to 50 liter, and yes, that's why we are saying that no fixed volume. And it can be squashed. It can be squashed. Yes? So these are the 3 different states of matter that we have just spoken about, that is solid, liquid and gas. Now once again coming to this, everybody try to understand this. We know that states of matter is solid, liquid and gas. Now the question comes, ma'am, can we interchange them? Oh yes, of course we can. We all know that, right? We all know that. Sure, let's write it down here. There is solids. Let's write solids here. Yes, let's write liquid here. And let's write gas here. Alright. Now if I want to change solids to liquid, okay? Now if I want to change solids to liquids, what will I do? Solid to liquid, everybody knows, no? What is that process? Solid to liquid. The process of converting solids to liquid is obviously nothing but melting. Am I right? You melt ice, what do you get? You get liquid, water, isn't it? Now, if I have to change liquid to solid, my dear student, if I have to change water to ice, what will I do? Freezing. Am I right? Yes, absolutely correct. Now, if I want to convert liquid to gas, what do I do? Evaporation. Everybody knows this, very basic, very simple. This is evaporation. Am I right? Great. Now, here, if I want to convert gas to liquid, what do I do? Gas to liquid. Once again, very simple, very easy. Condensation. Condensation is something that we will do, right? Now, let's say that I want to convert gas to solid. This might be new for you, my dear student. Gas to solid, when I try to convert, we call this process to be deposition. What do we call it? Deposition, okay? And when I want to convert solid to gas, you must have seen it, but I don't know if you know it. The process is called as sublimation, okay? What is sublimation? Have you seen naphthalene balls, mothballs? Yes. Sublimation is the process when, let's write it down here. Sublimation is the process when a solid directly gets converted to gaseous state without getting converted to liquid first, okay? The process when a solid directly converts into gas without first converting into liquid. Alright, Understood everybody? This is sublimation, okay? And deposition is, my dear student, what is deposition? Deposition is when a gas directly gets converted into solid, okay? Rest of the definitions you already know, but these two might be new for you, that's why I am writing it down. What is deposition? When a solid, when a gas directly gets converted into solid, okay? When a gas directly gets converted to solid. Alright, this is called as deposition. These are the two definitions. Now obviously in JEE you will not be getting questions from this, but it is very important that you understand from the basic and every concept is crystal clear in your mind. Now unlike in other teachers, I do not want to just jump into the the topics from where questions come. I also want to make sure that you learn everything. So I hope this is clear, okay? These are the conversions, and yes, these states are interconvertible. Now moving on from here, you know that we also have to study properties of matter, right? And when we talk about properties of matter, there is obviously two types of properties that come into our mind. One is your physical properties. Yes, one is your physical properties, alright? And the other one is definitely chemical properties. Alright? Yes? Now, in case of physical properties, what are the things that we talk about? Right? In physical properties, we talk about obviously states of matter. We talk about appearance and etc. Whereas in case of chemical properties, we talk about their acidity, basicity, combustibility, and all of these, okay? These are your chemical properties, okay? These are the properties of matter. Now, not only properties of matter, but you know that matter can also be classified into different categories. And why is classification or grouping matter into different groups so important? Well, that's because, like I said, there are countless number of matter. Didn't I give you the example that the water that you drink, the Coca-Cola that you drink, the air that you breathe, the stones that you throw, the pen that you write with, the pencil that you use, the eraser that you use, the food that you eat, everything is matter. So if there are such endless number of matter, obviously grouping them into different groups will make our work easier for us to read about the properties. And hence, matter is divided into two groups. One is pure substance and the other one is mixture. Now, what is pure substance? Whenever we say pure, do you understand we also say that pure gold, pure oil, pure this, pure that. What is this pure? When we say that something is pure, that means there is nothing else present in it, only that particular substance. For example, let's say that when I say pure gold, I mean to say, okay, I mean it's something like this, okay? I mean something like this. Let's just say that these are my gold atoms, okay? Gold atoms, gold atoms, gold atoms, gold atoms, gold atoms, gold atoms, right? Now this looks like pure gold because only gold atoms are here. Now what if I start adding, let's say, some amount of silver here, some amount of silver here, some amount of copper here, some amount of bronze here. Is this pure? This is not pure anymore. I wanted pure gold. If I wanted pure gold, then obviously there had to be only gold atoms. So when I say pure substances, what I actually mean is elements or compounds, which are basically the further classification of pure substances. So pure substances can be divided into two groups, that is elements like oxygen, hydrogen, lithium, iron, cobalt, cobalt, and all of these, yeah. Sodium, potassium, rubidium, cesium, francium, right? Copper, bronze, argent, silver, gold, platinum, correct? Nitrogen, boron, all of these are elements. The whole periodic table of elements, pure substances. Yes? Then we come to compound. Now in compound, we can have these doubts that ma'am, compound bole to NaCl, sodium chloride, or H2O, or carbon dioxide. You just now said that pure gold, only gold atoms, nothing else. Then how come when you are saying H2O, there is hydrogen also, there is oxygen also, how is this pure? Okay, listen to me. So when we say that compounds are also pure, I mean to say that, let's say that I want to drink some water. And when I want to drink some water, I want pure water. I don't want dust particles in it. I don't want grains of dal in it. I don't want grains of rice in it. I don't want some, some banana, banana, what do you call it? Banana skin in it. Do I want all of these? Will I be able to drink that water? No. I want pure, simple, normal water. And I mean to say that if I take a glass of water, then it should only have H2O, 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 H2O. Throughout the glass, it should only have H2O. That's all that I mean. And that is a pure compound. And the very same way, when I buy Tata Shuddh Namak or Ashirvad Namak or this salt or that salt, in the whole packet, I don't expect to see some dust particles or some stone pellets, nothing like that. Only thing that I want to see in that whole packet is NaCl, 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 NaCl. Throughout the packet, it should only have sodium and chloride particles, sodium chloride particles. That's what it should have, right? So pure substance, makes sense everyone? Makes sense or nonsense? So compounds like water, table salt, ammonia, these are all compounds, okay? These are all compounds, correct? Okay? Now, mixtures. Mixtures can be of two types, once again. Mixtures can be of two types. There can be homogeneous mixture and there can be heterogeneous mixtures. Now, when I say homogeneous mixture, okay, let's first talk about heterogeneous mixtures. Have you heard about mixtures like, the Haldiram's Tana Bana and that, in Bengali we have something called a Sholo Ana where there are 16 types of mixtures like peanuts, then there are mutter, peas, then there are those, bhujia thing, then there are those raisins and cashews and all of these. And is there a guarantee that every time I take a spoon of that mixture, can I guarantee that there will be 5 peas and 5 peanuts and 5 raisins and 5 cashews and 5 those bhujia thing? Can I guarantee that? Will there be uniformity? No. In certain spoonfuls, I might be getting 10 cashews and no raisins. And in the next one, there is a possibility that I'll be getting 2 peas and I will be getting 5 those bhujia thingies and nothing else. There is a possibility, but that means that there is no uniformity in it. Am I right? There is no uniformity in it, and that, my dear student, is exactly what is your heterogeneous mixtures. Alright, that, my dear student, is exactly your heterogeneous mixture. Let me change the color of the pen, okay? This is not a good one. So, heterogeneous mixtures are basically non-uniform. They are what? Non-uniform. Do you understand what is uniform? In school, you all go to school, right? In school, what do you wear? You wear uniform, no? In my days, we used to have like what? White shirt and blue color skirt. And everybody used to wear the same thing. Why? Because everybody has to look the same. Uniform, same, similarity, exactly. But in this case, there is no uniformity. Whereas when we talk about homogeneous mixture, there is a uniformity. They are uniform, okay? They are uniform. They are similar. They are same. Alright? Yes. So, homogeneous mixture in case of solution, let's talk about. Let's say lemonade. Yeah? In summer, we do have lemonades, isn't it? Does it feel like if you take 1 glass of lemonade, then what happens? Very salt. Very sweet. Very sour. Does it happen every sip? Does the taste change? No, not at all. The taste remains the same throughout the glass. That means there is uniformity. So in case of homogeneous mixtures, you will find uniformity, whereas in case of heterogeneous mixtures, you will not find any uniformity. Now here is another thing, okay? Elements or compounds, okay? Elements and compounds, they cannot be separated just like this. You will not be able to separate elements in the compounds with just normal physical, uh, normal physical reactions. You will not be able to. It's not possible, right? Like physical, how do I say? Physical methods as in hand picking, winnowing, threshing. Do you remember all of these? You have learned in your junior grade. You will not be able to separate them with these processes. You will require chemical reactions for you to be able to separate them. But in this case, they can be separated with physical properties as well. Understanding, they can be separated with physical properties as well. Alright? Now moving on from here. So since there are so many properties, since there are so many matter, we also do have to measure them, right? Yes? Don't we, my dear students? How would the world run, imagine, if we did not have anything to measure? Let's just say that I go to the shop and I tell them that potatoes. How much potatoes? Who knows? How many people do I have to feed with potatoes? Maybe 5 kgs, maybe half a kg, maybe 10 kgs. Without these units, without these measurements, don't you think that the world would have been really tough? Exactly. And then when we come to measurements, you know what do we have? We have some basic fundamental quantities. Apart from these quantities that is there in the list, apart from that, anything else that we have is completely derived from these. These are the basic fundamental units. You know, when I say basic means fundamental only. So these are the fundamental quantities. Apart from this, everything else that you have is actually derived. So let's just learn about that, okay? Mass is a fundamental quantity and the symbol of mass is small letter m, whereas SI unit of mass is kilogram and symbol is kg. Length is symbol is small letter L. Meter is the SI unit and symbol is small m. Time is T, second is S, second is the SI unit of time and the symbol is S. My dear students, please note, many students what they do is they write SEC. SEC is not the correct symbol. The correct symbol is only small letter S. Okay. Alright, then we come to current. Current is capital I. Yes, capital I. Don't get confused. This is capital I. Okay, this is letter L. Capital I, SI unit is ampere and symbol is A. Temperature, capital T. Name Kelvin, SI unit is Kelvin and symbol is K, capital K. Okay. Amount of substance. This is what the whole chapter is about. Okay. Amount of substance, symbol is N. Name of the SI unit is mole, MOLE and symbol is MOL. Alright. Luminous intensity. Symbol is I, capital IV. Name of the SI unit is candela and symbol is CD. Apart from these 7, there are 7 only, right? 1, 2, 3, 4, 5, 6, 7. Apart from these 7 basic fundamental units, everything else is derived. I hope you understand. Yes? Now let's read about them in detail. Okay? We just spoke about mass. Now please don't get confused that mass and weight are two different things. Mass is the innate property. Mass means the amount of substance that is present with something. Okay? Yes, whereas weight is actually a force. Weight is the product of mass and gravity. So weight might change. When you are on earth, your weight will be different. When you are on the moon, your weight will be different. But your mass will still remain the same, my dear student. Take a look at it. Mass 120 kg will remain the same. But your weight can be 200 Newton in moon and your weight might be 1200 Newton in earth. I mean on earth, not in earth. On earth, it will be 1200 Newton. So it will change, it will differ. Mass and weight are not the same thing. However, even as a grown-up, and I have heard many grown-ups, interchanging these two terms and they keep talking about it like mass and weight are the same thing, but it's not. Mass can be measured, right? Even in your laboratory with a simple machine, with a simple device, you can measure the mass. But for weight, you will have to calculate it with, yes, I just told you, it's a product, mg. That's your weight, okay? It's a force, right? Right, everybody understood? Okay. Moving on from here, let's talk about density. What is density? Density is the amount of substance or the mass per volume. That is your density. In fact, if I have to talk to you about density in layman's term, okay, in absolute layman's term, then density is basically the heaviness, my dear student. What is it? It's the heaviness. For example, what if I take a handful of cotton? Cotton, we clean our face sometimes. We use it to wipe our wounds and everything, right? That cotton. So if I take handful of cotton and if I take handful of iron, which one do you think will be heavy? Heavy. Which one do you think will be heavy? Obviously, the iron will be heavy, right? Iron will be heavy. Why? Because the density of iron is more. It will feel more heavy. Although both of them are like handful, same quantity. But it will still, this will feel a little heavy. Why? Because mass per volume is probably a little more for iron. Alright? And this is the formula. How do you calculate density? Rho is equal to mass by volume is your density. Now what is this? Is this P? No. This is actually the Greek letter RHO. It's pronounced as rho. Okay, this is rho. How do you write it? You write it like this. Okay, alright. Now this triangular thing you probably confused that what is this? Very easy. Now mass, volume and density. These are the three things that I am talking about here, right? For example, in your exam, if you are not able to figure out what is the formula, just do this. Write mass, write volume and write density here, okay? Draw a triangle divided into 3. Now see, very easily you will be able to get to know all the formulas here. See. Now ask me, what is the formula of mass? What is the formula of mass? Very easy. Volume multiplied with rho here. Okay, see, multiplied. Mass is density into volume. Mass is what? Density multiplied with volume. Alright. Now if somebody asks you, ma'am, what is the formula of density? What is the formula of density? Very easy. Mass divided by volume. Do you see? Mass divided by volume. If somebody asks, ma'am, what is the formula of volume? What is the formula of volume? What is it? Mass divided by density. That's it. This is what this triangle formula means. Okay. So once you draw the triangle in your rough work, very easily you can derive all the formulas. Alright. Very simple, very basic. Moving on from here. Now we come to another fundamental unit, that is temperature. Now my dear students, understand that temperature has 3 units which we very often use. Okay. But the SI unit we actually don't use much often. Right? Yes. For temperature, we mostly use degree Celsius, degree Fahrenheit and Kelvin. Please remember, what did I say? Degree Celsius, degree Fahrenheit. But in case of Kelvin, I haven't used the prefix degree because Kelvin does not have to be expressed as a degree. Kelvin is just capital K. So even when you are writing, you write it like this, okay? Degree Celsius, degree Fahrenheit and Kelvin. Alright, yes. Now many times you must have heard that the Americans, the USA, in the US, what do? They sometimes say that, oh, the temperature is 97 degree. And you must be like, whoa, what? 97 degree, your blood must be boiling. Actually, they are talking about it in Fahrenheit. Now the question comes that can we convert it into degrees Celsius? Of course we can. Of course we can. And here is the conversion formula. If you have temperature in degrees Celsius and you want to convert it into Fahrenheit, then what you have to do is you have to multiply it with 9 by 5 into degrees Celsius plus 32. Now you will ask me, ma'am, where does this number 9 by 5 come? Where does this number 9 by 5 come from, right? Let me tell you. Okay, let's understand this, okay? Yes. So the boiling point of water, please listen to this carefully. Boiling point of water in Fahrenheit is Fahrenheit is actually 212 degree Fahrenheit. Okay, all right. And the freezing point of water is 32 degree Fahrenheit. Now if we just subtract this, so 212 minus 32 will be 2 minus 2 0. This will be becoming 11 minus 3 is 8 and this is 180, right? Now if I do the same thing, for degree Celsius, take a look at it, okay? Boiling point of water is equal to 100 degrees Celsius, am I right? Yes. And freezing point is equal to 0 degrees Celsius. So 100 minus 0 is equal to 100. Yes. Now tell me something. Now if I do, I'm drawing it here, okay? 180 divided by 100, if I simplify 0, 0, then what? 9 here, 2 9s are 18, 2 5s are 10, so 9 by 5. Do you get the result? Do you get the number? Yes, you do. So this is where we get this number 9 by 5. Now from where is this 32 coming? Very simple, very easy. We just saw that 32 is the freezing point of water in degree Fahrenheit. Whereas in case of degree Celsius, it is only 0 degrees Celsius. So hence we use 32 here. Okay. Alright everybody. Now if I have to convert Fahrenheit to Celsius, all I have to do is I will just change the denominator to numerator and numerator to denominator. So 5 by 9 into degree Fahrenheit minus 32, this will be my conversion formula. And finally, if I have to change Celsius to Kelvin, please know that in case of Kelvin, what happens is 273.15. That is the actual number. However, we want to make our life easier. So what we have done is we have just taken 273. And if you are once again asking me from where is this 273 Kelvin, same thing, that boiling point, freezing point that I have told you, exactly like that. In case of Kelvin scale, that number is different. From that number is 273, which is why we write 273. That's it. Okay, this is the conversion. I hope you are clear with it. Yes? Now I have a question for you. Let's answer this. Tell me, a measured temperature on Fahrenheit scale is 200 degree Fahrenheit. What will this reading be on Celsius scale? Can you calculate? Or let's calculate. Chalo, let's calculate. So Fahrenheit scale is degree Fahrenheit. What is our formula? Fahrenheit to Celsius, right? Fahrenheit, it is given to us in Fahrenheit. We have to change it to degree Celsius. Sorry. Yes. So what we have to do? Degree Celsius is equal to 5 by 9 into degree Fahrenheit minus 32. So we have to do 5 by 9. Yes. Then what do we have to do? 200 minus 32. Isn't that? Yes, it is. So I think if you do it, let's use my mobile phone and let's calculate. Yeah. Let's calculate. So 5 by 9. What is it? Let's do it. Yeah, let's do it. Yes, 5 by 9 into, let's do 200 minus 32. What do we get? Oh, we get 93.3. That is option C. What do we get? We get option C, 93.3 degrees Celsius. Now, obviously, in JEE, you will not be getting these kind of questions. Not at all. Not possible. It's very easy, very simple. JEE will not give you these kind of simple questions. But maybe in your board exam, you might get a 1 mark MCQ like this. Okay? Chalo, no problem. Moving on from here. Now, let's come to scientific notation. Why are we studying this topic? Well, because I just told you that atoms and molecules is what chemistry deals with, right? In the whole subject of chemistry, we deal with atoms and molecules, which are very, very, very small particles. So small that we cannot even see them with our naked eye. Correct? Yes. So that means we understand that even if I take a small block of gold here, it will be having many, I cannot even emphasize more on the word many, but there will be endless number, that's what as a layman we will say, that endless number of atoms probably. But that's not the case, right? Now, just if I ask you that, please write it down in the chat box, you will probably write that, ma'am, it has one, then 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. Now for you to write in the YouTube chat must be very easy, because what are you doing? Copy paste, copy paste, copy paste, or 0, it will keep going, right? That's what you are doing, so it will be very easy. But if I ask you that in your JEE exam you have to calculate with this, by the way, mark my words, in JEE in the past years, regarding scientific notation, regarding significant figures, questions have come, okay? So now it is your time to focus a little more if you haven't been focusing. So just take a look at it, how our life has become easier, okay? If we write it in an exponential form, if we write the figures, if we write the numbers in an exponential form, of course, our life becomes easier. Take a look at it. Tera. Tera is a prefix. Now, obviously, the fundamental units you saw, the fundamental units cannot always be used because we might need a bigger unit, we might need a smaller unit. So, at that time, scientific notation allows us to use the prefixes for us to make our life easier. Yes. Now, if we need a bigger unit than kilo, what will we do? We will use the tera, giga, mega. Okay. Now see, take a look at it. The value of tera is basically 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 zeros in it. Now instead of writing so many zeros, can I just write it like this, 10 to the power 12? Yes, I can. Now you might also ask me, you might be confused and you might say, but ma'am, 10 and then there are 11 zeros. No. What you can see is that there is 10 here and then 11 zeros, right? Take a look at it. Acha. If I do 10 into 10, what will be my result? 100, right? But what actually is this? This I can also write it as 10 to the power 2. 10 to the power 2 means 10 into 10. It also means 100. So 100 can also be written as 10 to the power 2, right? Now this value means 10 into 10 into 10. 12 times if you multiply 10, that's when you will get this value. So 10 to the power 12, okay? Same like this, if it is giga, then you write 10 to the power 9. If it is mega, you write 10 to the power 6. If it is kilo, then it is 10 to the power 3. If it is a deci, then 10 to the power minus 1. Okay. Now here things change. See, deci, 0.1. What does 0.1 means? 0.1 means 1 by 10. Now in mathematics, you have read that if it is a denominator, if 10 is in the denominator, then you can also write it as 10 to the power minus 1. So make sense how we have written it? Same like this, if it is 0.01, that means it is 1 by 100, isn't it? 1 by 100 means it is 0.01. So that means 10 to the power minus 2. Making sense? Same like this, milli means 10 to the power minus 3, micro means 10 to the power minus 6, nano means 10 to the power minus 9, and pico means 10 to the power minus 12. But that's not where it stops. It actually, there is yocto, zepto, femto. Yes, all of these are also there. All of these are also there. That is possibly there in your NCERT book. If you want, you can just take just take a look at it. Otherwise, this much is also enough for you. Okay. Alright. But yeah, please do note these symbols. Yes, these symbols will be required when you are doing your numericals. Alright. So scientific notation is absolutely clear for you, I hope. Yeah. Easy peasy biryani is tasty. Please do write it down if you are understanding all the concepts, and please do comment easy peasy biryani is tasty, so that even in Vedantu people understand that Nabamita Ma'am is teaching good. Okay? Yes, and don't forget to like the video, guys. Don't forget to like the video. Chalo, moving on from here. Now here is a term that many students get confused with: accuracy versus precision. So there is a lot of blah 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 things written here, and you might not be able to understand. You might be thinking, what is it? Cannot understand. Let me show you a picture here. Let me show you a picture here. Accuracy versus precision. So do you see that dartboard? You know how you play? You keep throwing things. You keep throwing. And it goes, and if it hits the bullseye, then you're like, yay! Yeah? Exactly. Okay. So if you use this dartboard, right, and you have used the darts to throw at the board, what happens is, see, all the 3 darts are at the center. So that means that this has good accuracy and good precision. What did I say? The first picture has good accuracy and good precision. Yes, because all the 3 of them are very, very, very close to each other. Right? Okay. Now coming to the second picture, do you see that this is the bullseye? This red part is the bullseye, but this is not where the darts are. The darts are way off. They are here at the edge. So that means that this has absolutely bad accuracy, so poor accuracy. It is not at all accurate. Not at all accurate. But do you see that all the three of them are right there? So I will say that this is good precision. This is good precision. Alright? Yes. Now look at this. Neither are the darts close to each other, nor are they hitting the bull's eye. So this, my dear student, is both bad accuracy as well as bad precision. As well as a bad precision. Alright? Yes? Understanding everybody? Got it? Now let's come to the theory part. So, the theory part says that precision is the degree of closeness of the measurements with each other. And it says that accuracy is the degree of closeness of the measurement to the target or reference value. For example, let's just say that, okay, top of my mind. Let's say that we are in chemistry laboratory and we are doing an experiment, and I have told you all students that, hey, the value has to be 10. The value has to be 10.0. Now, let's say you, my dear student, let's say you are Rahul. Rahul, you get the result to be 10.2. Alright? Yes? Now, can I say that you are accurate? Probably, yes, you are accurate, because your accuracy is just a difference of 0.2. Alright? Yes? Getting it? Now, there is another student, let's say that Sharmila. Now, Sharmila has repeated the experiment quite a few number of times. Sharmila did not do the experiment just once, but Sharmila did the experiment thrice, and she gets the results. Let's say that she gets it around 10.3, 10.3, and let's say 10.4. Now, these results are close to each other. What is the precision? The precision is only 0.1. See? The values only differed by 0.1. So, precision is the degree of closeness of these values. These values are very close to each other and the difference between them is only 0.1. Whereas accuracy is the what? Is the degree of closeness of measurements to the target. This was your target, right? This was your target. Getting my point? Yes? Alright everybody, so this is the difference. In fact, from here you can understand it even more. This graph shows the precision. If all the values are in this graph, then this is your precision. This is your actual target reference value, and from here if your value is this is the value that you are getting, then this is your accuracy. Alright, understood everybody? Understood the difference? Got it clear? Crystal clear? Easy peasy biryani tasty? Amazing. I will be giving you the PDF, so don't worry about making the notes. The PDF will be given to you in the Telegram channel. The link of the Telegram channel is given in the description box. Please do join it. And after I have finished all the sessions from this chapter, you will also be getting it in the description box. But right now, if you want the notes fatafat, if you want the notes fast, then please do join the Telegram channel. Alright? Moving on from here, accuracy versus precision is understood. Now tell me something, which of the following is the most accurate measurement? Here is something that I haven't spoken to you about, but let's see if you can find it out. Tell me. Which of the following is the most accurate measurement? Is it option A 9 meter? Is it option B 9.0 meter? Is it option C? Okay, sorry. This should be 9.00 meter. Sorry, there was a error. And this is option D 9.000 meter. Do you know what is the answer? Let me tell you. The answer actually is option D, because this has 4 significant factors. What did I say? Option D has 4 significant factors. Significant figures, sorry. It has 4 significant figures. And more are the significant figures, we consider the value to be more accurate. Now you might be asking me, ma'am, what are significant figures? Significant figures are basically the certain number that is present, okay? The certain digits that are present. Now there are rules that if a 0 is here, if I write a 0 here, then will it make sense? Will the 0 have any value? No. So then the significant figures won't change. It will still be 4 significant figures. It will still be 4 significant figures. But if I write it as 0 point, here a 0, and then if I write it as okay, now tell me how many significant figures are there? What do you think? Will there be 1, 2, 3, 4, 5, 6, 7, 8? Will there be 8 significant figures, or will it be 1, 2, 3, 4, 5, 6? The answer is 6 significant figures, okay? 6 significant figures. Understood? So there are rules. If there is a 0 between 2 certain digits, then the 0 will be counted as significant figures. If there is 0 just before a decimal point, it is not counted as a significant figure. But if it is after a number, it is counted as a significant figure, okay? So that rule is there in your NCERT. Just read through it. I think you will be able to understand. It's very simple, okay? Alright, so option D is the correct answer. Next question for you. Tell me, 18.72 gram of substance X occupies 1.81 centimeter cube. What will be its density measured in correct significant figure? Let's do it. Very simple, very easy. What is it asking? It's saying that 18.72. That means it is a mass. Yes. So we are given mass. Mass is equal to 18.72 gram. Then it says that it occupies this centimeter cube. That means this is the volume. So volume is equal to 1.81 centimeter cube. Right? What is it asking? It's asking us to find the density. Find the density. Chalo, let's find it out. We all know what is the formula for density. Density is equal to mass by volume. That means 18.72 divided by 1.81. What will this give us? This will actually be around 10.34 gram centimeter cube. Okay. Now, you might be thinking that option B is the correct answer because this is what you got. But guess what? What will we do? Here, be very careful. Now look at this. This only has 3 significant figures, right? 1, 8 and 1. 3 significant figures. Because volume has only 3 significant figures, what we will do is, we will only consider till 3 significant figures. And that, my dear students, will make us write this as the correct answer. Option A, 10.3 will be the correct answer. Understood, everybody? But it's, I think, is there a, have I created something? I think there is a, no, actually, yeah, 10.4. No, it should be 10.3 only. It should be 10.3. This is the correct answer, okay? This is the correct answer, not this. Or maybe I have made a mistake somewhere. No, but this should be the correct answer. So 10.3, or maybe we can round it off and we can write it as 10.4 also, okay? But 10.3 should be the correct answer. Anyway. Alright, so do we have we understood? Now, let's go to laws of chemical combinations for elements and compounds. Why? Because we know that in chemistry, elements do combine to form compounds, and there are, what is it? Transformation of atoms and molecules. And all of this transformation that happens, they are actually governed, they are actually dictated like puppets by these chemical combinations. There are actually 5 chemical combinations that we are going to read now. Alright, so the first one is law of conservation of mass. The law of conservation of mass says that mass can neither be created nor destroyed. Of course. Okay, imagine me eating, going to the Burger King, going to McDonald's, going to KFC and just, eating. There will be balance in the universe, no bro? What will happen? I will become like this, isn't it? Now, just so that I don't be like this, what am I doing is, I am eating but lesser amount, and I'm also working out, right? While I'm working out, while I'm going and doing my exercise, and I'm also eating less, now what will happen? All of this KFC and Burger King and the McDonald's that I've eaten, now it will slowly reduce. So what is happening? Universe में balance. There is balance in universe. You eat, you will gain. You don't eat, you will not gain. So mass cannot be created, cannot be destroyed. It remains as it is. But how are we using it in chemistry? Of course we are. In chemistry, what happens? Reactions happens. And how do we write reactions? There are reactants on one side, there are products on one side. So what we mean is, the amount of reactants that you take must be equal to amount of products. Amount of reactants that you take, if you take 50 gram and 50 gram, it should be equal to 100 gram. It cannot be 101 gram, it cannot be 99 gram, it cannot be 102 gram. No, 50 plus 50 will be 100 gram always. Alright, it remains constant. And that's what we mean when we are saying that mass cannot be created, mass cannot be destroyed. Now, do you know who gave it? Nobody will ask you, but it's a good to know. It's a general knowledge. Antoine van Leeuwenhoek. Sir Antoine Leeuwenhoek was the one who gave this theory, who gave this law in the year 1789. Alright? Now, moving forward from here, we have something called as law of definite proportions. Who gave this? This was given by Joseph Proust. He was a French chemist, and he stated that the proportion of elements by weight in a given compound will always remain exactly the same. So what he meant is, let's say that if I take some copper carbonate from nature, and if I take copper carbonate synthetic, and if I make copper carbonate synthetically in a laboratory, then the amount of copper and the amount of copper and the amount of carbonate in the natural copper carbonate and the amount of copper and amount of carbonate in the synthetically produced copper carbonate will be same. It doesn't change. So basically, if I take H2O from Australia and if I take H2O from India, it will have the same proportion. The weight of hydrogen and the weight of oxygen in H2O from wherever you take it, it is going to remain exactly the same. Understood? Yes? So regardless of the source, doesn't matter. Origin or its quantity, doesn't matter. You take 1 liter of water from Australia or you take 10 liter of water from America, it will still have the same, exactly same weight of hydrogen and oxygen as it is supposed to be. That's your law of definite proportions. Understood? Very simple, very easy. Moving on from here, then we go to law of multiple proportions. What is this? This means that this law states that if two elements combine to form more than one compound, the masses of these elements in the reaction will be in the ratio of small whole numbers. What does it say? It says that law states if two elements combine to form more than one compound. For example, let's just take the example of hydrogen, right? So we know that hydrogen plus oxygen forms water, right? So if I take 2 gram of hydrogen and if I take 16 gram of oxygen, I will be getting 18 gram of water. Now I also know that hydrogen plus oxygen also gives me hydrogen peroxide. Am I right? But in this case, if I take 2 gram of hydrogen, I will have to take 32 gram of oxygen, and then what will I get is, I will get 34 gram of hydrogen peroxide. So do you see that 16 and 32, what is the ratio here? 16 is to 32. I can simplify it and I can write 1 is to 2, right? What is this? This is a simple whole number. This is a simple whole number. 1 is to 2. Exactly what is this law saying? Alright. Now what happened? So these were all about solids, right? These 3 laws were perfectly about solid. Now we come to this this law called Gay-Lussac's law of gaseous volume. Now we have come to gas. And this law states that when gases are produced, when they combine in a chemical reaction, they do so in simple ratio by volume. It's gas, right? Now we can't talk about mass all the time. We have to talk about volume, given that all the gases are at the same temperature and pressure. Now this law is actually very similar to this law of definite proportions. Only difference is this is in mass, this is in volume. Yes, law of definite proportion is in mass and this, my dear student, is in volume. Alright, yes everybody, understanding, got it? Now because in the name itself it is written Gay-Lussac, so obviously Sir Gay-Lussac would have given the law. Cool, alright? Moving on from here. Now we come to this gentleman's name, that is Avogadro. Amedeo Avogadro. His name is actually very big. Yeah, his name is almost as big as the Avogadro constant, that is 6.022 into 10 to the power 23, right? So Avogadro proposed, he said that, let's draw it and understand. So let's say that here is a container and here is another container. Okay? Let's say that here I have 2 liters of hydrogen and let's say that here I have 2 liters of carbon. Let's say that here the temperature is 300 Kelvin and here also the temperature is 300 Kelvin. Here let's say the pressure is 1 atmospheric pressure. Here also the pressure is, let's say, 1 atmospheric pressure. Now this law states that if the temperature, the pressure and the volume of the gas is the same, then the number of molecules will also be equal. Isn't it beautiful? It is beautiful. I really like this law. It's amazing. Of course, I mean, you don't fall in love with one law, but yeah, what it means is, see, now read this. It's stated that under the same conditions of temperature and pressure, the temperature and the pressure are same, 300 Kelvin, 300 Kelvin. 1 atmospheric pressure, 1 atmospheric pressure. If the temperature and the pressure are same and if they have equal volume, 2 liter, 2 liter, same volume I have also taken, right? Then the number of molecules that the gases contain will also be same. Get it? Beautiful, isn't it? Beautiful, isn't it? Yes? So that's what Avogadro said. Now all of these are fine. Apart from this, there is another law which might be required for your JEE. Not JEE also. I'm so sorry, this technical glitch always happens when, when you take Google Slides to this thing. You know what, let's just, I don't want to give it to you like this. I do not want to give it to you like this. So what I'm going to do is, I'm just going to fix it here. Yep. This is better. Ha. This is much better. Isn't it? Much better? Yes. Alright. So, law of reciprocal proportions. Alright. Now, what this says is that it states that when two elements combine separately with a fixed mass of third element, then the ratio between their masses in which they combine will either be same or it will be once again, simple multiple of the ratio. Look at it here. Copper plus sulfur. Mistake. This is supposed to be CS. What is this supposed to be? CS. Alright? Yes. Now what will happen is when Cu plus S, yes, CuS is forming, see 63.5 you have taken. Now if copper is reacting with oxygen, see what is happening, once again 63.5. Now if sulfur reacts with oxygen, see 32 gram and here 16 gram, right, O2, so 32 gram again. So do you see how they are reacting? It is the same or it is a simple multiple of the ratio. It is a simple multiple of the ratio. Get it, my dear students? Yes. Do you get it what I am saying? Do you get it what I'm saying? Yes? So this is what we mean here, okay? This is your law of multiple reciprocal proportions. Now, moving on, I have a question here. Tell me how much mass of silver nitrate will react with 5.85 gram of sodium chloride to produce 14.35 gram of silver chloride and 8.5 gram of sodium nitrate if law of conservation of mass is followed. Option A is 22.85, option B is 108 gram, option C is 17.0 gram, or is it option D 28.70 gram? Till then, I'm just going to move aside and drink a little water. Guys, come on. It's very easy. What do we have to do? What is written here? Come on, have we thought about it? Sure. Let's take a look at it. So as per law of conservation of mass, what is it given? How much mass of silver nitrate is produced? So AgNO3 plus react with sodium chloride, so NaCl, will give you, yes, silver chloride, so AgCl plus NaNO3. Now, as per law of conservation of mass, all of these are supposed to be equal. Or I can just write that M reactant is supposed to be equal to mass of product, isn't it? Now, what's given to me? Let's say that silver nitrate I do not know, so let's count it as X. NaCl I know that it is 5.85 is equal to AgCl is 14.35 plus 8.5. Yes, now calculate it. Now calculate it, everybody. Chalo, let's calculate it. Let us do it, okay? Let us calculate it. What is it? Let's do it. 14.35 plus 8.5 is equal to 22.85 minus 5.85. It is 17. The answer is, of course, option C, 17.0 gram. Got it? Clear? Yes, so option C is the correct answer. Alright. Now tell me which of the following statements best explains the law of conservation of mass. Let's read the statement. 100 gram of water is heated to give steam. It doesn't make sense, right? Why will this be related to conservation of mass? Now, a sample of nitrogen gas is heated at constant pressure without any change in mass. This also does not make sense. 36 gram of carbon combines with 32 gram of oxygen to form 68 gram of carbon dioxide. 2 plus 6 is 8 and 3 plus 3. This is law of conservation of mass. Option C is law of conservation of mass. 10 gram of carbon is heated in vacuum without any change in mass. Once again, does not make sense. Option C is the correct answer here. Alright? Yes? Now, which of the following pairs illustrates the law of multiple proportions? What did he say? Law of multiple proportions. It's supposed to have, remember, hydrogen and oxygen, what did it give? Water and hydrogen peroxide. And in this case, none of them have similar elements except this. So, option B is your correct answer. Pretty simple, pretty easy, right? Yes. Now, here we have a question from JEE Mains. However, this you will not be able to solve because in this case mole concept is required. So we will be trying to solve this in the next episode of this lesson, which will happen on Monday 7 p.m. I will be seeing you with these questions plus more theory, where we will be reading about Dalton's atomic theory, we will be reading about atomic mass, molecular mass, molar mass and molarity, normality, stoichiometry, all of this till how much ever we can. Yes, and we will be trying to solve some more examples, more questions as well. So with this note, for today, I will be saying goodbye to you. I hope that you understand everything that I have taught you. But please don't just think that it is so simple that we don't have to read it just because you are in 11th standard. My dear student, please understand that this is the very basic of your chemistry. If you understand this clearly, you will be able to do the other things also much easily. Alright, with this note, tara bye-bye. Have a nice evening. Lots of love. I'll see you next time. Bye.